Martin Air Flight 495 is minutes from landing at Faro, Portugal.
The left engine was making a rattling sound. All of a sudden, we heard an enormous bang. It was total destruction.
56 people are dead.
Wow, look at this.
Investigators quickly find some intriguing evidence at the crash site.
There was a 2-inch deep cut down the left side of the runway.
This is very strange.
The landing gear is completely severed.
If the aircraft were overweight, it could exceed the design limit, causing it to break and shear.
These guys were 71,000 pounds underweight. It wasn't too heavy. So what went wrong?
Martin Air Flight 495 is nearing Portugal's southern coast.
Approach, Martin Air 495. Good morning.
The captain is 56-year-old H.W. Van Staveren.
75 DME and out of 240 for level 70.
A highly experienced pilot and flight instructor. He's been with Martin Air for 24 years.
Descending to level 70.
The first officer is 31-year-old R.J. Clemenkoef. He's been flying with the Dutch company for 3 years. The youngest member of the team is 29-year-old flight engineer Gary Glanz.
It was our last flight before the Christmas holidays. Everyone was in a good mood. My job as a flight engineer, I'm responsible for the aircraft in general to make sure that everything is operating properly and overall trying to be a third set of eyes for the flying pilots.
The crew is flying a DC-10, a 3-engine wide-body jet.
In the 90s, the DC-10 was one of the type of aircraft most used for operators worldwide.
They're now less than half an hour from landing. There are 13 crew members and 327 passengers on board. Most are residents of the Netherlands.
We were heading for a vacation for a week in the south of Portugal, in the Algarve. Going to warmer weather than the Netherlands was and fleeing the busy year we had.
Flight 495 is near the end of a 2.5-hour trip from Amsterdam to Portugal's Faro airport.
8-letter word for apple sources.
Orchards.
I was traveling with Yvonne, then my girlfriend, now my wife. I was lucky we could sit at the front row, so I had a lot of leg space to move around.
Oh. Raining cats and dogs over there.
As they descend towards Faro Airport, the pilots expect to encounter some bad weather.
We knew that we were going to encounter rain showers. Thunderstorms are something that you have to be incredibly aware of and ensure that they don't affect your flight path. We do everything to avoid them because they can produce unexpected wind changes, microbursts, wind shears.
When a thunderstorm moves over an active runway, the potential for wind shear can make it too dangerous for an aircraft to land.
It wasn't something that we felt was going to be a major issue. It was just something to monitor.
If the weather worsens, they can divert north to Lisbon. But right now, it isn't necessary.
Martin Air 461, runway visual.
Just minutes ahead, another Martin Air flight is landing at Faro.
Clear to land, runway 11.
The weather report indicates the closest thunderstorm is approximately 7 miles to the west of the runway.
Knowing other airplanes were flying that same approach and nobody had reported any significant issues made us feel we were safe to continue onwards.
495 is turning inbound.
8 miles out, Martin Air 495 starts its final approach to runway 11.
The captain chose to be the pilot monitoring so he could oversee the whole approach and let the first officer focus on just flying the aircraft.
They descend into the rain clouds, confident the nearest thunderstorm is still miles away.
Runway surface conditions are flooded.
Roger, 495.
With wet runway conditions, the crew configures the plane to make what's called a positive landing.
A positive touchdown is when the main wheels penetrate the water layer on the runway and improve the stopping ability of the aircraft.
Gear down.
Gear down.
With a wet runway, you do want to touch down at a positive, firm rate rather than trying to float down for a softer touchdown.
Altimeters set 3 times.
4 miles from touchdown, the pilots make their final checks.
Spoilers.
Arm.
Flaps, slats.
50, land.
The left engine was making quite a noise and a rattling sound every time it gave full power. The plane was pitching up and pitching down. So that was not reassuring.
Martin Air 495 cleared to land runway 11. The wind 150, 15 knots, maximum 20.
Clear to land.
Flight 495 is less than a minute from touching down, when the weather gets much worse.
Windshield anti-ice. I can't see anything.
I'm on it.
Wipers are on fast.
It's okay. It's okay.
I was squeezing hands firmer and firmer with Yvonne. It was dead quiet in the plane.
The plane is now just a few seconds from landing.
All of a sudden, we heard an enormous bang. I fell out of the chair, and then I saw the kitchen splinter into pieces.
I was pretty sure we were going to be crushed.
Flight 495 slides more than 350 feet off the runway at Faro Airport. Firefighter and rescue crews race to the site. Incredibly, many of the passengers and the flight crew survived.
There were people screaming and crying and running.
I didn't see my girlfriend. My first thought was, oh, I won't ever see Yvonne again.
Those lucky enough to escape search for loved ones.
All of a sudden, I heard my name. Then I saw in the distance, I saw Yvonne standing there. We found each other.
The injured are taken to nearby hospitals. Of the 340 people on board, 54 passengers and 2 cabin crew members are dead, making this one of Portugal's worst aviation disasters in more than a decade.
A detailed investigation is now underway into why this plane hit the tarmac and burst into flames.
See if we can find the flight recorders.
Got it.
Investigators from Portugal's General Directorate of Civil Aviation and from the American NTSB arrived to inspect the wreckage of Martinair Flight 495.
A DC-10 is a big aircraft, and there were pieces of it all around. The right wing had dislodged from the rest of the aircraft. The wing structure is the strongest structure on the whole aircraft, so it had to have a major amount of stress to make that wing depart.
It's amazing so many survived.
The wreckage showed that the aircraft was mostly destroyed by fire. 80 to 90% of the people who died from the post-impact fire.
We were very concerned because if you have something that's suspect on an aircraft that's being flown all over the world, you want to find it.
That's great. Nice work.
Let's hope we get the data back quickly.
Investigators recover the black boxes containing the flight data recorder and cockpit voice recorder.
We needed to try to understand what happened in the final moments of the flight, in terms of speeds, in terms of decisions, and also what happened just before touchdown.
Wow, look at this.
A quarter of a mile from the runway threshold, investigators discover the aircraft's initial point of impact.
There was a 2-inch deep cut down the left side of the runway.
So it hit here and then veered off to the right.
It's deep. They must have come down hard.
The scratches we saw on the runway revealed to us that the plane had landed very hard, so that's why the marks were deep.
Maybe one of the engines failed.
Why did the plane land so hard? Was it a problem with the landing gear? Was it a problem with speeds, or was it a problem with the engines? So we need to investigate that.
Is that all of them? Let's see what we've got.
You always look at the engines, and there was substantial damage. We had to determine, was there some kind of malfunction in the engine?
Investigators examine a key component from the engine's oil block called a magnetic chip detector. A magnetic chip detector is a small cylinder-shaped device located inside the engine's oil filter. When an engine part wears, pieces or chips of broken metal adhere to a magnet as they pass through the oil filter.
It's known as making metal. Why is there more metal on this detector than expected? What part of the engine is wearing? The alloys are slightly different. They wear at different rates. So they can tell by laboratory analysis what part of the engine is wearing and how rapidly.
These look clean. No chips.
There's no evidence of metallic debris inside the oil system.
The engines look fine.
From the tests conducted on the engines, it was concluded that the engines did not contribute to the accident.
At this point in the investigation, we really didn't have a good idea of what to look for next. We just had to keep going.
Oh, this is very strange.
They soon realize that part of the right landing gear is broken.
The fact that part of the right landing gear fractured is very unusual. It's almost impossible to make it fail.
The forces necessary to shear the landing gear like that is massive.
Landing gear is designed and tested to be able to withstand the shock of a 200-ton landing. It should never fracture.
We had to confirm whether there was something wrong with that gear in the metal used or maybe the maintenance on it, anything that could cause the gear to fail in any way. And if it was a design problem, that's a big deal.
The landing gear failing on impact would explain this tragic accident.
Did we get this piece of landing gear in yet?
Not yet. We're rushing.
The landing gear collapsed. That was perhaps the most important question that we had to deal with.
While investigators wait for the right landing gear of Flight 495, they consider what could have caused it to fracture.
Maybe the plane was too heavy.
If the aircraft were overweight and made a very firm touchdown, then the loads imparted could exceed the design limit, causing it to break and shear.
Let's check the load manifest.
The plane and the cargo were roughly 280,000 pounds. There was 340 people on board. Let's call it 53,000 pounds.
And fuel?
Fuel was 20,000 pounds.
So total weight on landing was 353,000 pounds, give or take.
Max weight is 424,000 pounds.
So, these guys were 71,000 pounds underweight. It wasn't too heavy.
The weight of the plane is not what caused the landing gear to fail on touchdown.
What about weight distribution?
You have to have the baggage and the weight distributed properly so the aircraft will fly the way the pilots want it to.
By the book.
It was properly loaded, properly stored, properly locked down, so it wasn't really an issue.
With weight and balance ruled out, investigators are finally able to test the right landing gear itself.
Service records are up to date. Let's see if the steel wasn't strong enough.
Another thing they were looking for is any pre-existent weaknesses on the steel. If this occurred in the manufacturing process, it could affect the aircraft in operations all around the world.
They perform something called a Vickers hardness test.
The Vickers hardness test is an industry standard test to evaluate the strength of a particular component or piece of metal.
A pyramid-shaped diamond is pressed into the steel, leaving an indent or dimple.
You can measure the depth and the diameter of the dimple and derive the metallurgical strength of what you're testing.
Hardness value 658. So the steel was strong enough.
Investigators find no weakness in the metal used to make the plane's landing gear.
It was determined there was nothing wrong with the landing gear. Whatever went wrong, it happened before the aircraft touched the runway.
There are still no clues that can help explain why the landing gear fractured.
The next step in the investigation was to look at how the crew was operating during the last phase of the landing.
This is interesting.
Official statements made by the pilots may shed some light on the final moments of Martin Air Flight 495.
After the accident, the investigators came to all three of us We had closed sessions.
The captain said the flight was normal. The approach was normal. At 200 feet, we were on the center line. So they should have been okay. But a few seconds later, the captain sees lightning. I suddenly felt a high sync rate. It all happened so fast, the aircraft actually fell out of the sky.
According to the captain, he saw lightning just seconds before the aircraft began to lose altitude rapidly.
Sync rate.
The airplane felt like God took his hands, rammed it into the ground.
Well, get this. The first officer stated the weather was bad and it was raining heavily. It was gusty and very turbulent.
Investigators wonder if sudden wind changes could have contributed to the crash of Flight 495.
The flight crew indicated to the investigators that they were in an area with a lot of wind shear, a very dynamic weather condition. They were in turbulence, things were changing very rapidly.
Did the pilot encounter wind shear on final approach? The team interviews the air traffic controller to better understand the conditions the pilots were experiencing.
Can you tell me what happened with Flight 495?
Everything seemed perfectly normal. They were on their final approach and confirmed they had the runway in sight. Then I cleared them to land.
Partner 495, clear to land runway 11.
The wind, 150, 15 knots, maximum 20.
The controllers were quite confident that they performed well the tasks, so they didn't find that they did anything wrong, and they gave the correct information.
Did they report any issues with the plane?
No, not at all.
What about the weather?
There was rain, but other planes were taking off and landing without difficulty.
Partner 461, runway visual.
Just minutes before the crash, the controller was in contact with an aircraft that took off and another that landed on the same runway.
Cleared to land runway 11.
Neither flight reported extreme weather over the runway.
What about wind shear? Did the runway sensors pick up anything?
Faro Airport is equipped with two anemometers that measure both wind speed and direction, located on runway 29 and runway 11. If the anemometers detect a sudden change in wind speed of 15 knots or greater, a wind shear warning is automatically triggered.
Yes, there were wind shear warnings, but they happened after the aircraft had already crashed.
If Flight 495 was hit by an extreme gust of wind before it crashed to the runway, the system would have detected it. It didn't.
There was a conflicting information between what the crew said and what the air traffic controller reports.
The crew's statements don't match the controller's account of the weather.
Thank you.
The best thing to substantiate what went on was to take a really deep look at what the pilots were saying to each other in the cockpit.
Let's start with their approach brief.
A week after the crash of Flight 495, data from the cockpit voice recorder is ready to be reviewed.
Fly the approach with 50 flaps. You call approaching minimums and field in sight. You look outside. Wet runway.
And here are the wipers.
Roger.
As the crew prepares for the approach, they become aware of weather conditions at Faro Airport.
You have to make a positive landing.
Yes.
Okay. So, obviously they're worried about the runway conditions.
In a positive landing, the aircraft touches down firmly enough to penetrate the water, allowing the wheels to grip the tarmac and slow the airplane.
They want to put it down hard to avoid hydroplaning and running out of runway.
So what went wrong?
Did the pilots somehow botch their plan as they approached the runway?
$500. Cleared. Speed a bit low. Speed is low. Low. Okay. Now speed is an issue.
Going onto a wet runway, the airspeed control is very, very important so that you don't have too much and the airplane floats, but that you don't have too little and you end up impacting the runway quite hard.
All right, let's hear more. Speed is okay.
Windshield anti-ice. I can't see anything.
I'm on it. Wipers are on fast.
As the plane gets closer to the ground, the crew contends with stormy conditions.
A bit low. Low. Yes. Throttles. Why does the captain yell throttles?
For the captain to say this at this moment, it raises the question, did they have an issue in the final phase of landing?
All right, let's look at the descent profile.
If Flight 495 flew in on the right trajectory, the FDR will confirm it.
Here you go.
The flight data recorder gives objective, clear data on what the airplane was actually doing. Was the airplane being flown at the proper speed? The changes in the airspeed, were they indicative of a severe weather condition, and how were the pilots responding to those changes?
Autopilot is on.
Okay, so they're descending at the standard angle, and they dip here and recover. Looks fine.
At 200 feet, which is about 20 seconds from landing, they were on a normal glide path. Something happened between that and touchdown.
Let's look at the airspeed data.
So, looks like they're flying steady at 145 knots until here. And airspeed jumps and then drops all the way to 139 knots.
Investigators spot evidence of airspeed fluctuations during the last minute of the flight.
These fluctuations in airspeed can be caused by wind gusts as they get closer to landing.
Speed is a bit low. Speed is low. Speed is okay.
Was the captain concerned their speed wasn't fast enough to compensate for the strong headwind?
Yeah, these fluctuations seem too extreme to be caused by the 20-knot winds reported by the controller.
We need a full analysis of the weather conditions on final approach.
Investigators asked the Netherlands Aerospace Laboratory to perform an in-depth weather study to determine if the winds were stronger than what was reported to Flight 495.
What about auto throttle data?
Let's take a look. Yeah, the fluctuations in auto throttles correspond to the airspeed fluctuations.
If there is an increase in airspeed, the autothrottle system will decrease the power that is being commanded, the amount of thrust that the engines are producing. If the airspeed falls low, the autothrottle system will command increased thrust to bring the airplane up to the commanded airspeed.
The auto throttles were indeed adjusting for the dramatic changes in airspeed.
Wow, look at that. 102% power.
Investigators discover a very high surge in engine power, 3/4 of a mile from the runway threshold.
The 102% command by the autothrottle system is a massive amount of power. It would be similar to the amount of power that you would use for takeoff. Too much power to try to land with.
And then here, power drops to 40%.
The team discovers that the power dropped to a minimum, or engine idle, shortly thereafter.
That's way too fast for the autothrottle system to perform on its own.
For the engines to decelerate as quickly as they did means that the levers were moved faster than the autothrottle clutches can physically move them.
The only way the throttles would move that quick would be if the pilot was manually adjusting them down to 40%.
The autothrottle system could make large corrections, and you have to make manual adjustments if the throttles aren't keeping up.
The first officer, who was the flying pilot, made the decision to override the autothrottle system and to pull the power way back. And in fact, he pulled it all the way back to flight idle.
With so little power, they would have dropped like a rock.
According to the data, they were dropping 1,000 feet per minute.
1,000 feet is well beyond the operational limit of 600 feet per minute for the DC-10.
As a consequence of the reduced power, the plane hit the runway with enough force to crack the landing gear.
I've never experienced a landing as hard as that. I crushed my teeth in my mouth. It was hard beyond compare.
Investigators are left with a key question.
Why would the crew reduce power by so much, so far from the runway threshold? This is the Dutch weather report.
Investigators turn to a weather analysis prepared by the Netherlands Aerospace Laboratory to determine if the weather affected the crew's actions during their final approach.
Looks like the weather was worse than we thought.
Really?
They hit no less than 3 separate microbursts in the last minute of flight.
Wow, okay.
A microburst is a column of air that descends from rain clouds, hits the ground, and fans out horizontally. It leads to significant fluctuations in a plane's airspeed.
When exactly?
The first one was at 700 feet. The second was between 600 and 300 feet. And the last one was between 200 and 110 feet. Now, this last one was the worst. The wind speed jumped from the reported 20 knots to 40 knots.
Wow. That would have triggered a wind shear alert if one was installed on the plane.
Then the wind shifts from a headwind to a tailwind.
A sudden shift from headwind to tailwind is the worst type of wind shear because a headwind improves your angle of attack to ensure that the aircraft has good lift. When the wind switches around to a tailwind, you lose that aerodynamic performance. If you don't have the thrust to compensate for it right away, the aircraft will drop.
Let's compare this to the autothrottle data.
They line up.
For every microburst, there's a corresponding increase in engine power as the autothrottles try to maintain the plane's speed.
The autothrottle was going up and down. It was struggling very hard to fight against those heavy downbursts.
The downburst causes a decrease in stability, which means turbulence-induced roll and pitch oscillations.
Would have been a bumpy ride.
Yeah.
As they passed through each microburst, the auto throttles were adjusting to the shifts in wind gusts.
In the final moments, the approach was under extreme weather conditions. There were a lot of oscillations in speed, and that created a lot of stress for the pilot flying at that time.
The first officer likely would have been overwhelmed by the unexpected change in the weather.
And knowing that he needed to make a positive landing at the runway threshold, he sees the power spike to 102% and takes corrective action.
In order to get the plane on the ground, the first officer overrides the auto throttle and reduces the power to idle. Investigators now see just how unfortunate his timing was.
He cut the power at the exact same time that last downburst hit them.
Throttles!
The captain tries to stop the plane's uncontrolled descent, but he's too late.
The captain should have stepped in sooner.
He should have recognized something was not right. The captain really should have taken over and landed himself.
Investigators suspect the sudden change in weather, combined with the pilot's decision to cut power too early, caused the aircraft to land with more force than it was built to withstand. But one question remains unanswered.
If the winds were gusting at 40 knots a half mile from the runway, wouldn't the winds at the runway be gusting stronger than the 20 knots reported by the controller?
The team returns with their findings to the air traffic controller who oversaw Martin Air Flight 495.
You reported that the winds on runway 11 were gusting up to 20 knots.
That's correct.
But that doesn't seem right. The Dutch weather study confirmed that there were 3 microbursts in the last minute of flight, with gusts much higher than that. Can you show me the actual data for runway 11?
According to the raw data, the winds were actually gusting at 35 knots.
Oh, that sounds more like it. But how could you have underreported the wind conditions?
We receive wind data every 30 seconds from this device. It must have been switched to runway 29. Instead of runway 11.
Investigators discover that air traffic controllers at Faro Airport had mistakenly selected the wind reading on runway 29 instead of runway 11.
Airports are large places, so when you have anemometers on opposite ends of the airport, you would expect that frequently there would be a difference in direction and velocity of a reported wind.
Martin Air 495, cleared to land runway 11. The wind, 150, 15 knots, maximum 20.
Clear to land.
The controller's information that they provided to the crew was not representative of what was actually occurring on the runway.
Wet runway, crosswinds, that's a completely different picture. If the pilots were aware, they would have gone around.
Investigators have figured out what brought down Flight 495.
.495 is turning inbound.
495, copy.
Report at minimums or runway in sight.
Runway surface conditions are flooded.
Roger, 495.
Gear down.
Gear down.
With the runway at Faro underwater, the crew plans a positive touchdown at the runway threshold.
Clear to land runway 11.
The wind, 150, 15 knots, maximum 20.
But they're unaware of the severity of the weather conditions.
I can't see anything.
I'm on it.
They're hit by a series of unexpected microbursts, causing the engine power to shoot up automatically. Concerned that the excess power is too great for a positive landing, the first officer reduces the power to idle just as the last microburst occurs.
That makes them vulnerable to strong winds. And the aircraft dropped from 150 feet.
Take break.
Flight 495 slams to the ground at 1,000 feet per minute.
The danger of being slow and encountering a downdraft is you may not be able to recover in time, and that can be disastrous.
They could have come with a higher speed. They could have performed a missed approach. But the truth is the flight crew tried their best. This wasn't an accident where we can see negligence or gross error.
In the aftermath of their report into the crash of Martin Air Flight 495, investigators make a series of recommendations.
This accident was going to be yet another example of inappropriate wind shear recovery being applied in a timely fashion. So this says additional pilot training. This says wind shear detection systems on airplanes. This says a more aggressive approach to go-arounds in unstable conditions.
Shortly after the crash, Faro Airport modernized their wind sensors and displays to comply with international regulations.
The critical information that controllers provide to pilots needs to be accurate. So these are some of the lessons that the industry learned and implemented following this accident.
You know, one of the things I was told when I was becoming a pilot is never let your guard down. You can be having a beautiful, wonderful flight, and in the blink of an eye, things can change. It's just ingrained in my mind. Always be ready for the unexpected.